All right, example number 3 here, the special results. What happens if we do the following? So let's look at this first one. You should remember when we divide, as long as the bases are the same, and the bases are the same here, they're both an 8, then we're allowed to subtract the exponents. So we have 8, 3 minus 3 is 0. And you should know that anything to the 0, there's a special number that gets. Remember, I think we did 100 to the 0 one time. And anything to the 0 is 1. In the same case here, G, both of these bases are G, so we can subtract 5 minus 5 is 0. Now you've got a letter to the 0. That is also 1. This letter can be any number that's chosen. It's called a variable, so G is a variable, and that means we can choose G to be 100 or 1,000,000 or negative 55. But whenever we have a number and then it goes to the 0, we always get 1. So that's what this special case is here. Any letter or number to the power of 0 will always be 1. The other thing that comes from this, and this is kind of sneaky, so we have 8. That is our base, so we are allowed to subtract. We need to subtract the exponents here. So I have my 8, and then I go 7 minus 10. Now 7 minus 10 is actually negative 3. And when you have a negative exponent, what you're allowed to do is, in most cases, so for everything we do, we're allowed to bring that to the bottom. But you might be wondering, the bottom of what? I just have a number. But just remember that there's always a number divided by 1. There's always a denominator. We just don't always see it. So it's all over 1. So we can bring that 8 down, and we can bring that 3 down, and we can change that negative 3 to a positive 3. And then what number's up top? Well, there's no number there, so it's a 1. So the rule is, if you subtract an exponent and you get a negative 1, just bring it to the other side of the fraction and make it a positive. So here I have an x, and I have a 5 minus 8, because I'm dividing. I can go 5 subtract 8. That gets me negative 3. Math people don't like negative exponents, so they bring it to the other side of the fraction, which is weird because there is no fraction. So we're going to put it over 1, and we're going to bring this thing down below. So we'll bring it down below, but instead of a negative 3, I'll make it a positive 3. And there's nothing up top here, so we need to make sure we put a 1. And that's what you're going to see here. Whenever there is a negative exponent, we're allowed to bring it to the other side of the fraction, which again, there is none, so we have to put it over 1, and we can just bring this thing down. And then we can make it not a negative m, or in our case, a negative 3, but we can make it a positive m, or a positive 3 in our examples. So keep all of that in mind as we do these next examples. So there is the third law, and that is the power law. And that says if you have an exponent that goes to another exponent, a power to a power, you get to multiply those. So it's very straightforward. This is 2 to the power of 3 to the power of 5. So 2 to the 3 to the 5. Because you have a 3 to the 5, you have a 5 is a power and 3 is a power. They're both exponents. I've got 2 exponents here. Then I can multiply them. 3 times 5 is 15. It doesn't matter how many exponents there are. If there's an exponent to an exponent to an exponent to an exponent, multiply them all. Here, I can multiply my exponents, and I get 14. So it's just 5 to the 14. Here, my base, it includes the negative, so I have a negative 4 as my base, and then exponent and exponent gets me a 9. Moving on, I got an a to the exponent and exponent. 10 times 5 is 50. And then I've got a b, 5 times 10 is 50. So notice there I had a 10 and a 5, or I have a 5 and a 10. Both of them ended up getting me 50. So it doesn't really matter which order I put them in, because in the end you multiply. And multiplication doesn't matter what order. So in this case, we both get 50. Let's keep moving on here. Ooh, this is interesting. This is an exponent and another exponent, so I am allowed to multiply. 3 times -5 is -15. But now we got to remember that special case where if you have a negative, you got to bring it down below. So I'm going to put a denominator there, and a 1. And so I can move the 2 to the -15 down below onto the denominator, because right now it's up in the numerator. So now I'll move it to the denominator, but I made it a +15. And I'll have to add that 1 up there because there's nothing else. So if you have a negative exponent, make sure you move it to the denominator. Okay, what do I have now? Oh, I've got a -4 as an exponent and a -2. So -4 times -2 is actually a +8. A negative times a negative is a positive. So that worked out quite nicely. I don't have to move anything. Those negatives canceled out. Now I've got an x, I've got 3, 4, and 2, so I can multiply all of those. 3 times 4 times 2. So 3 times 4 is 12. 12 times 2 is 24. And lastly, 2, 3 times 4 times 0. So 3 times 4 is 12. 12 times 0 is 0. So really this is 2 to the 0. But there's a special case that says if you have something to the 0, the whole thing just becomes 1. So 2 to the 0 ends up becoming 1. So I'm going to zoom out. We've got one more section, and you can see it's titled Combined Laws. So we'll do multiplication, division, and the power law, and that's what a lot of the test stuff is on. The basic test questions are what we've just done, a basic multiplication or division or power rule, but the combined laws, that is where you really need to know your stuff. So we'll do that in the next video.